We're going to do another lesson on unit rate, and this time we're going to make up a table of our values that we find, and from that we can build a graph. Alright, so let's take an example. Suppose I hike half an hour every fourth of an hour. What is my unit rate? And how far do I hike in 2 hours? Well, one way to do this is to make up almost like a little block here, and I know some elementary schools do this. So let's put this in. This is a fourth of an hour, and I go half of a mile. This is another fourth of an hour, and I go another half of a mile. And a fourth, and I go a half and a half. And so at the end of my whole hour, I have gone half, 1.5, 2 miles in 1 hour. And that is my unit rate of 2 miles per hour. Okay, so that is one way to do this, and you can use these little sort of block diagrams for a lot of different reasons. Alright, so let's make the table. We're going to do hours, and we're going to do miles. Because now I know my unit rate of 2 miles per hour, I can fill out a table with some different values. And I don't just have to use whole numbers for this. So in 1 hour, I go 2 miles. Well, in twice as much time, I'm going to go twice as far, 4. And in 3 hours, I can do 3 times as much, or 6. And now we can see that our miles, if we take our hours, we multiply by 2, our unit rate, and get how many miles we've gone. So the answer to my question is, what is my unit rate? My unit rate is 2 miles per hour. And my table shows me how far I hike in 2 hours. That will be 4 miles. Alright, so what we did was we made a sort of a block diagram, and then we made our table. Now I could graph it and look at different values on the graph. But there's another way to solve these problems, and that's using complex fractions. Now, a lot of students shy away from complex fractions because they seem at first to be hard, but they're really not that complicated. Alright, so we know that unit rate for this problem, still doing my hiking half a mile in a fourth of an hour, I want miles divided by hours. Okay? So I'm going to take my miles and divide what I have by the hours I have. So I have 1/2 divided by 1/4. And when you have fractions in either the numerator or denominator of another fraction, it's called a complex fraction. Here I have them in both. Sometimes I have them in one or the other. But you see, basically a fraction here, this is a division problem. So this can be rewritten as 1/2 divided by 1/4. And now you know how to solve those because we've worked with fractions, and we do the keep, change, flip. So we keep the first term, change to multiplication, and flip the second term. We use the reciprocal, as it's called, of the second term. And now I multiply and solve for 2 miles for 1 hour. And so what looked to be complicated at first, really once it was written in this form, is not as complicated as it seemed and is easily solved. So that's another way we can solve those, because we knew we wanted miles divided by hours. So we got the same answer for that one. And again, we could now go on to building a diagram and a graph for that problem. Let's look at another problem, and this time it's painting. I painted 8 square feet every 12 minutes. How many square feet can I paint in 8 hours, in an 8-hour day? Alright, so we've got our in. Okay, what I'm going to use here is one of the problem-solving strategies that I like the best. And that is to make a simpler problem like the one you have and solve it. Now, I have made a problem here that I painted 20 feet in half an hour because I already know the answer to that question. I already know that if I'm doing 20 feet in half an hour, then I can do twice as much. So I know the answer is 40 feet in 1 hour. All right, I know that because it's half an hour and 20 feet and so on. Well, what I'm going to do is see if my unit rate fraction here works, or ratio. Here, 20 divided by 1/2, because we take feet per hour. This can be rewritten as 20 divided by 1/2. And to do that, I would have to make that into a fraction, which I can do by putting it over 1. And now keep, change, flip using the reciprocal. Then my answer is 40, which I knew. Well, what does that tell you? I already knew the answer, so what does that matter? Well, the reason it matters is because now I can use this method in this question. And there's a couple of ways I can do that. Time is tricky. It's very hard to put time into decimals because time isn't measured in 100 minutes to an hour or 100 seconds per minute. It's in 60s. And so that doesn't translate very well to decimals. You can't just say 0.12 of an hour because that's 12/60ths, not 12/100ths of an hour. So I'm going to use this method here, and I can do it a couple of ways. If you know that 12 minutes is 1/5 of an hour, I can divide 8 by 1/5. And that will keep the numbers slightly smaller. But if I don't even know that, suppose I just know that it is 12 out of 60. Then I can use this method that I know works because I got the answer I knew, and that was correct. I can take this, rewrite it. Nothing's changed except its form. I'm going to make that into a fraction, which I can. And now I'm going to keep, change, flip. And it really would be simpler if I did simplify that. So if I know my 12 times tables, I should know that that is 60 is 5/12. So I'm going to go ahead and simplify here that I have 5 and 1. Now, 8 times 5 is 40. 1 times 1 is 1. So here, my 40 square feet goes over 1 hour. Now, it is purely coincidental that this turns out. I wasn't trying to find the answer here. This was a simpler question I used because I used half an hour because I knew I could double what I did in half an hour to make it an hour. So this is a coincidence. It's not that your easier problem that you make will come out to be your answer for the bigger problem, so why even do it? That's not the point at all. I just made an easier question. I made easy numbers here. I didn't say it was 17 and a half. I didn't say it was anything difficult. I said 20 and half an hour so that I could easily compute the unit rate of 20 feet per hour. And then I just used that same strategy here, the method over here. And again, we could have done this 8 divided by 1/5 here and showed it here. If you know that. But if you don't have something like 12, if you had 10 minutes, then that's 1/6 of an hour. If you had 15 minutes, that's 1/4 of an hour. But if you don't know, you can always use how many minutes out of an hour. And when you change it to this form, it becomes a much easier problem for you to deal with. So these complex fractions that we use are really not as hard as they seem at first. At first, this seems a little intimidating. So this is how to find a couple of different unit rates We can then go on to make tables, and in another video we will take these tables that we can make and make them into graphs. And as we said previously, another name for unit rate is the slope of the graph, or constant of proportionality. And I want you to remember those three names are all the same thing. Unit rate, constant of proportionality, and slope. Those all refer to the same thing when we are talking about proportional relationships.